It's Mrs. Lemke. Today we are going to look at some connections between the graphs of quadratic functions and the solutions of quadratic equations. As an opener, I'd like us to revisit the two topics we've studied most recently, which is solving by taking square roots versus solving by factoring. And so there are 6 questions in this warm-up, and for each of these problems, I want you to consider if you would solve using square roots or using factoring, and then go ahead and solve. We'll do a couple together, and then I'm going to ask you to do a couple on your own and come back and check, okay? So to begin with, let's look at problem number 1. And I notice here that there are basically 3 terms. If I get this to standard form, by moving 5x to the other side, subtract 5x from both sides, and subtract 6 from both sides, I'd end up with this equation. And this is not something where I can isolate the term that has a square. There's too many terms. There's 3 pieces here. So this is one where I would solve by factoring. There's no GCF to pull out. So I'm going to think about how I would distribute or how I would FOIL, quote unquote FOIL. So to get the x squared, I would need an x and an x. 6 at the back could be 1 times 6, or it could be 2 times 3. So I'm going to think about which of those would be better for that middle term. And it might not be obvious right away, because I can see ways that, 6 minus 1 makes 5, and 2 and 3 together make 5. So it might not be very clear at the beginning, but then you have to think about the pluses and minuses, and it should become more clear. So if I use 6 and 1, to have a negative in front of the 6, I need to have 1 negative and 1 positive. And so the signs in this manner would give me negative 6x and a positive 1x, which makes my middle term negative 5, okay? If I did try to use the 2 and the 3 and said, okay, well, I have to have negative 2 and negative 3 to make negative 5, when I multiply this out, I would get negative 2 times negative 3, which would mess up the sign right in here. It would make that a positive 6. So so hopefully that explains to you why it is the factored form that I have there in blue pen. And so we're going to go and set each of those equal to 0. And so I would have x minus 6 equal to 0, and I'd have x plus 1 equals 0, which is going to give me the solutions of 6 and negative 1. Those are my 2 solutions for that. Okay, so that one was done with factoring. Question 2, let's take a look. Now this one has a slightly different format. It has fewer pieces, fewer terms. So in this one, I'm going to go with the strategy of using square roots, because I can just isolate that part that has the exponent on it and then use a square root. So I'm going to divide both sides by 2 to try to get the x squared term alone. And then I'm going to take the square root of both sides. And so remember that when you have an unknown entity squared, so an unknown like x or something that contains an x, if I have x squared and then I take the square root, the other side of the equation picks up a plus and minus symbol. It could be either positive or negative, right? Just because when you take a negative number squared, you get a positive. When you take a positive number squared, you get a positive. So when I'm looking at x squared equals 12, this number that I'm squaring might be positive and it might be negative, okay? Then the square root of 12, that's not a perfect square, but I know that 12 is 4 times 3. So root 12 is root 4 times root 3, and root 4 is 2. So I have positive 2 root 3, and I have negative 2 root 3. Those are my 2 answers. All right, I'd like you to pause the video, and for each of these questions, think about if you are going to use square roots or you're going to set each factor equal to 0. Number 3 is actually partially done for you. It's already in factored form, so I hope that's the way you choose to go there. It's already halfway done. All right, so try 3, 4, 5, and 6. and come back to check your answers when you have completed those questions by yourself. Okay, so number 3 already was in factored form. So I certainly hope you said you wanted to use factored form strategy, not square root strategy. So set each factor equal to 0, and you get the solutions I've highlighted there. Question 4, it works very well if you just go with what you have and isolate that square. So divide both sides by 2, take a square root. You notice in my answers, instead of writing the plus minus symbol, I wrote one solution with a plus and one solution with a minus. You don't have to do that. You can write 3 plus or minus 2 root 10. That would be fine. I just know that sometimes students forget that when that plus minus symbol means 2 different things. It means a plus and it means a minus. So it's 2 different solutions. And so I like to try to emphasize that from time to time just to help our brains remember that. Question 5, also use square root of 40 if you went with isolating the square root. So that was kind of nice because you'd done that in question 4. And question 6 is really more amenable to setting up with factoring. So add 10 to both sides, and it's a pretty, hopefully, straightforward factoring question. Okay, and then your solutions are -10 and -1. So let's get to the meat and potatoes of today's lesson. So on the top of the next page, you'll see that we are just reminding you of the difference between a quadratic function and a quadratic equation. So a quadratic function is where you have y or f of x equal to, and then you have your standard form for a quadratic, right? We graph that, it makes a parabola. A quadratic equation is the same type of thing in that you still have, like a standard form sort of thing, or you could put it into standard form, but what you have here is equals 0 instead of equals f of x or equals y. And so these things are related to each other in that if we graph a function and then we think about an equation, those are related in that it's sort of like taking the y and replacing it with a 0. And in any mathematics, if you were to take something that is a graph and just take the y and say, I'm putting in 0 for y, well, what you're finding are the x-intercepts, right? Because every single point on the x-axis, every single one of them, all infinitely many points on the x-axis, they all are something, comma, 0. And so if we're putting in 0 in place of a y-coordinate, if we're putting 0 in place of a y in an equation, what we are finding are the x-intercepts. We're looking to see where that graph crosses the x-axis. Okay, so I know you're listening to this video, but I'd like you to also open up a tab on your computer for the graphing calculator aspect of Desmos. So you'll be here and you'll just type that you want to go to desmos.com and open your graphing calculator. Okay, so I'd like you to do this yourself, right? Just because, or to have this open because I'm going to ask you to do some questions yourself. The first one I will do here. It is in your notes packet, and now it's also in your video, right? But you'll have Desmos open to do the other problems. Okay, so you see in your notes, it says, I'll show you. It says that there are some problems we're trying to solve. Okay, so this is a quadratic equation, right? It just has equals and 0. Okay, it does not have y. Now, what I would like to suggest, though, is in trying to solve that, we can look at a related function. We can look at this equation. Okay, so the only thing that's different is we swapped out the 0 to be a y so that we can make a graph of it, right? Graphs require 2 variables, right? That's why we have 2 axes, an x and a y axis. Okay, so we're going to go over to Desmos and make that graph. So I've got y equals x squared minus x minus 6. Okay, so here's my picture. And I'd like to draw this picture into my notes. Okay? And so I'd like you to do that too. You can put this picture right into your notes. I'm going to use my technology tools, maybe. We'll see. I say maybe because you never know with me. I'm not really very techie. I'm not covey, you know what I mean? Okay. Yeah, something like this. Okay, so you could draw that into your notes like that. I'm regretting these purple lines. Messing with my idea of neatness. Okay, here we go. All right, so we have a picture like this. And I would draw that by hand. I'm just doing this to make my notes look nicer. Okay, so if I'm looking at this equation, the way that we did with the warm-up, I would say, well, you know, I know this factors. That's a pretty standard factoring question, which means I'd get answers of 3 and -2. But if you look at my picture, folks, look at this, right here and right here. 3, -2. Those are my x-intercepts. So the answers for the problem were 3 and -2. Now, did I have to actually have factored to know that? I actually didn't. Because if I just knew this connection between solutions and the picture, I'd say, oh, here's my equation, here's the graph of that, here are my x-intercepts, those x-intercepts are my answers. Boom. Okay, well, that's a lot of arrows. I just looked back. I don't know if that helped clarify. Maybe it just made notes messy. Okay, so what I'd like you to do now is there are five more problems where I'm asking you to take a look at the related equation on Desmos, draw a little picture of what the graph looks like, and then tell me in the last column what the answers are for your original problem. Okay, so you're going to go fill in this whole chart. Use on your computer, use the Desmos graphing tool, right? So just edit this equation that you have typed in from before, be the next problem, and come back to the video as soon as you've completed that. Okay, so let's check how you did. So for each one of these, as you go through, you just take this original equation that you have and rewrite it as a function by just putting in y instead of 0. And then you look on your Desmos graph for where the x-intercepts are, and those give you your solutions. So for number 2, you should have 6 and 2. For number 3, you should have +0.5 and -3. And remember, I didn't think of showing this on my screen until later on, but you can just hover, right, on the Desmos graph and it will tell you the ordered pair. So if you're not really sure, right, like when you looked at this problem number 3, if you weren't really sure of exactly where that point was, you could see it was between 0 and 1, but you weren't sure exactly where. If you just hover on the graph, it will tell you that you are at 1/2, 0. Okay, for 4, 5, and 6, this is what you should have seen. Number 4 has a parabola that goes way down low, so I didn't cut that part into my picture. I didn't try to worry about fitting that into that little box, because the part that we are interested in are these x-intercepts. So it really doesn't matter where that vertex is, because I'm just really looking for where does this graph cross the x-axis. So double check your answers for 4, 5, and 6. Make any edits that you need to. If something is strange or confusing, pause the video and go look at Desmos again. It's possible to have a typo on Desmos that throws things off, so make sure that you know how we got these. Okay, and now what we're going to do is make use of this chart to try to show ourselves a little strategy in case we are stuck with factoring at some point, like we just are having a hard time with factoring. Okay, so question 7 is referring back to the chart. Okay, so this problem in the chart was this problem right here, problem 4. Okay, and in problem 4, we found out that the x-intercepts were -4 and 3.5. Okay, so we know the x-intercepts are 4, 0, and 3.5. Sorry, -4, 0, and 3.5, 0. Okay, so what we're trying to do is write our factored form. So I know that if I get a solution of -4, right, x equals -4 is the solution, means that I have a factor of x plus 4. And this part's a little unusual because we haven't had decimals so much, but I would think that that means that I have a factor maybe of x minus 3.5, okay? So that does seem a little strange. So if we were to try to multiply this out, notice I'd have x times x, and that's going to give me x squared, not 2x squared. And I need a 2x squared. So I know that there has to be a 2 as well, okay? And you can be very clever with this because these are the two things that would be really most advantageous to multiply together, because then I won't have a decimal. Remember that if you have three things multiplied together, like let's just say three numbers, like 2 times 7 times 4. If I wanted to, I could do the 2 times the 4 and get 8, and then take that answer times 7. 8 times 7 would be my problem. So here, I want to put the things I highlighted in yellow. I want to push those together first. So let's write it in that order. And then the x plus 4, I'm not even going to worry about yet. Okay, so distributing that 2 is going to bring me back to not having decimals. And that would be really, really nice. I'd like to have some whole numbers going on here rather than decimals. Okay, so we'll distribute where I showed those green arrows, and I'll have 2x minus 7, and then I still have x plus 4, and then I'm going to multiply that out. So this would be 2x squared, and then outer would be 8x, inner would be minus 7x, and last would be negative 28. Ooh. Trying to squeak that 8 in. Okay, and then if I combine like terms, do I get what I had at the beginning? Is this factored right now? Yeah, these two together would make that plus x in the middle. Okay, I'm running out of space. That's my struggle right now. Okay, so I'm going to borrow from down here and then take it back later. So I'd have 2x squared plus 1x minus 28. And that's what I had. So my factored form is something I can figure out if I understand x-intercepts very well, right? So this is my factored form of, I keep changing too fast for the eraser to figure it out, of this equation, okay? So this is the factored form of the equation that I started with. Okay, and now the tricky aspect was just remembering that the 2 must be there. If standard form comes out to have 2x squared, there had better be a 2. Okay, that can't not be the case. Okay, and then finding that 2 is what got us to get rid of the 3.5. That's like awkward. Okay, all right. Now, if you look at the factored form, if we just had this as factored form, look at where we would have gotten the 3.5 from. We would have set each factor equal to 0. We would have solved that equation. We would have gotten 7 divided by 2. You know what that is? 3.5. Okay? So the decimal solution that we had did come from one of these factors, or could have come from one of those factors. Okay? Let's look at number 8. Number 8 says, look back at your chart and find 4x squared plus x minus 5. That was number 5, okay, in our chart. And the solutions there were negative 1.25 and 1. So we had x equals negative 1.25 and 1. Okay, so that would imply a factor of x plus 1.25. Again, that's sort of weird, the decimal there, something has to adjust. And then the x equals 1 is a factor of x minus 1. When I look at this, I know that if I multiply out this part in red, I'm only going to get an x squared. But I want to get 4x squared. So there has to be a 4 here. Okay, I'd like you to pause at this point and do what we did in the previous question. Distribute that 4 through, and then multiply out the whole thing. And you should get this standard form equation. Okay, go ahead and pause and try that. All right, and then number eight, you should have finished up. There's my work. And number 9 has a typo. I just caught it right now here making this video. So number 9, obviously, if we look back, there was one x-intercept, but only one. Why only one? Everything else had 2. Well, that happened because the vertex was the one and only solution. So if the vertex is an x-intercept, that means the turning point of the parabola is either like this, like we saw in that question, or it might be like this. And there's just going to be one solution in both those cases. So I have a question. Will there always be a solution? Right? Most of the time we saw something, whoops, that is not what I wanted to do. Okay, so most of the time we saw parabolas where there were 2 crossing points. The last problem we saw had a parabola with 1 crossing point. Could we have 3? Could we have none? That is a question we will be picking up. Thank you so much, and make sure to take these notes and have them handy while you do your assignment. Thanks.